In ethylene, one pi bond is present. So this is pi orbital, that is bonding molecular orbital, and this one is a pi star, that is anti-bonding molecular orbital. Now let me tell you what is node. Here this is positive sign and this one is also positive sign. So here there is no node, that is zero node. It's positive and negative. So give here node. Due to this, what happen? That positive becomes negative and negative becomes positive. So this is known as a node. Here one node is present, here no node, that is zero node is present. Symmetric properties of this ethylene molecule. Now here you see mirror plane symmetry and C2 axis of symmetry for pi bond and pi star bond. Okay. Mirror plane symmetry means, consider here mirror. So this one is mirror image of this one. That means with respect to mirror, these two orbitals are symmetric. That's why this is pi bond. So pi bond with respect to mirror plane symmetry is symmetric. Okay. Here you place mirror. So what happened? Positive. And this one is negative. That means having opposite sign. So this is asymmetric with respect to mirror plane symmetry. So pi orbital is symmetric with respect to mirror plane symmetry, whereas pi star orbital is asymmetric with respect to mirror plane symmetry. Now how to see this C2 axis of symmetry? By rotating it by 180 degree, what happens? This positive becomes negative and negative becomes positive. Now these two are not symmetric, that's why orbital with respect to C2 axis of symmetry is asymmetric. By rotating this orbital by 180 degree, this positive sign becomes negative and negative sign becomes positive. Now by doing so, what happens? Now positive, positive, these come on upper side. That's why this orbital is symmetric with respect to C2 axis of symmetry. These are the molecular orbitals of butadiene. So this is known as first approximation, this is second approximation, this is third approximation, and this one is a fourth approximation. In 1,3-butadiene, as you know, there are 2 pi bonds, that means 4 p orbitals. Now you observe Psi1. Here maximum overlapping is possible. It is 4 upper lobes having positive sign. So here maximum overlapping is possible. That's why it is at lowest energy. Then you see Psi2. That means here you just give one node. One node means what you have to do? That rotate this orbital by 180 degree. Rotate this orbital by 180 degree. So you get position like this. That means positive negative, then it is negative positive. That means here node is given. Okay, this is known as one node. So one node is given. After that there is no node. That's why this negative becomes. So by negative. Giving one node, what happen here? You just see overlapping positions like this. So there are 2 overlapping positions. Now see Psi3. Here you have to give 2 nodes. So one node is here and another node is here. Okay. So here what happened? This is node, that means positive negative, then node, that means negative positive, no node, so negative positive, then one node, so that there is a positive negative. Okay. Then Psi4. Psi4 means here 3 nodes are required. 3 nodes means 1, 2 and 3. So due to this what happened? All lobes having alternate positive and negative charge. While observing symmetric property, you just concentrate on these 2 lobes. Okay. Now similar to ethylene molecule, here these two are positive, that means mirror plane symmetry, this is symmetric. This one with respect to mirror plane symmetry, it is asymmetric. This one with respect to mirror plane symmetry, it is symmetric. And this one with respect to mirror plane symmetry, asymmetric. So in this way, this is tabulated here like this, that psi 1 is symmetric, psi 2 asymmetric, psi 3 symmetric, and psi 4 asymmetric. Then, with respect to C2 axis of symmetry, let us discuss symmetric properties of butadiene. Here you observe again signs. This is positive, positive. That means by rotating it by 180 degree, these two orbitals are not equivalent. That is, this one is asymmetric. Then this one is symmetric. Then this one is asymmetric, and again symmetric. These results are tabulated here in this way. Psi 1 asymmetric with respect to C2 axis of symmetry, psi 2 symmetric, psi 3 asymmetric, and psi 4 symmetric properties of hexatriene. Again, we are going to concentrate on these two orbitals, only these two orbitals. So with respect to mirror plane symmetry, this is symmetric. This one is psi 2 orbital is asymmetric, psi 3 is symmetric, psi 4 is asymmetric, psi 5 is symmetric, and psi 6 is asymmetric. That means here, as you see, symmetry is alternate. Symmetric, asymmetric, symmetric, asymmetric, symmetric, and asymmetric. These are tabulated here in this way. So psi 1, psi 2, psi 3, psi 4, psi 5, and psi 6. Symmetric, asymmetric, symmetric, asymmetric, symmetric, asymmetric with respect to mirror plane symmetry. Now let us consider the C2 axis of symmetry. Again we have to follow the same procedure. So by rotating it by 180 degree, what happens? That negative becomes positive and positive becomes negative. And that's why these two are now not symmetric. That becomes asymmetric with respect to C2 axis of symmetry. So this is asymmetric. This one is symmetric, psi 3 is asymmetric, psi 4 is symmetric, then psi 5 asymmetric, and psi 6 symmetric with respect to C2 axis of symmetry. And same results are shown. This is C2 axis of symmetry, psi 1, psi 2, psi 3, psi 4, psi 5, psi 6, asymmetric, symmetric, asymmetric, symmetric, asymmetric, and symmetric. Symmetric properties of sigma bond. As you know, sigma and sigma star, that is sigma bonding orbital, and sigma star means anti-bonding orbital. So this is sigma orbital, and this one is a sigma star, that is anti-bonding molecular orbital. Now let us discuss the symmetric properties of these two molecular orbitals. Now here, this is sigma bond. By placing mirror here, these two orbitals are symmetric. That's why this sigma is symmetric with respect to mirror plane symmetry. Okay. Now here by placing mirror, what happened? These two are not symmetric. That's why sigma star is asymmetric with respect to mirror plane symmetry. Now by rotating this orbital by 180 degree and observe, this orbital becomes symmetric with respect to C2 axis of symmetry also. Whereas this sigma star orbital, by rotating it by 180 degree like this, and you just again observe, so it becomes like this. Now these two are not mirror image of each other. That's why this sigma star is asymmetric with respect to C2 axis of symmetry.